Right, student, we continue back on unit vector. Okay, for the unit vector, okay, this is the unit. Okay, look at the figure here. This is 3 dimension. We have three axes here, x, y, and z. So what is unit vector? For example here, okay, look at this explanation first. Unit vector is used to indicate the direction of a vector. Okay, you should know the purpose of learning unit vector, to indicate the direction of a vector. The unit vector along x-axis is denoted as I. X-axis denoted as I. And then along y-axis denoted as J. And along the the z-axis denoted as K. So I, J, K. So when I say J, automatically in your mind, J is in Y axis. If I said K, unit vector K, that means that is the vector is along Z axis. Okay. Figure 2.8 shows how I, J, K are oriented in the X, Y, and Z. This is figure 2.8. So for I, okay, I is along X axis, J is along Y axis, K is along Z axis. Okay, what is X, Y, and Z? That means it is in 3 dimension. Before this, before this you learn about 2 dimension, which is X and Y axis. Okay, now here, okay, this is the figure here, but now the figure here shows not only X and Y, but another axis is K. Okay, that means this is 3 dimension. Okay, this is 2 dimension, this is 3 dimension. Okay, right, if you want to find, okay, any positional vector, for example vector A, its unit vector is given by, okay, this is unit vector, this is unit vector. Okay, unit vector. You can find the unit vector by using this formula. Unit vector A is equal to, okay, A cap means unit vector, and then is vector A, this is vector A. Vector A here is in terms of I, J, and K. That means you express, okay, you write the vector here in terms of I, J, and K. In terms of I, J, and K. And then here, what is this one? This one is the magnitude of vector A. Okay, now let us see how we are going to use how we are going to find the unit vector. Okay, look at example 2.11. Okay, example 2.11. For example, here you are given vector A. Vector A is equal to 10 meter with an angle of 60 degree. And then vector B, 10 meter, okay, with an angle of minus 150 degree. Compute the magnitude and direction and unit vector. You can see here, compute the magnitude. This is the first one you have to find. And then the direction, you have to determine the direction. And the last one is the unit vector. You have to find 3 answers for this question. Look at number 1. We want to find the magnitude. Okay, to find the magnitude. Solution number 1, to find the magnitude. Okay, the first one is you have to draw the... okay, let me draw here. You have to draw the position of the vector in X and Y axis. Okay, this is X. Okay, vector A. Vector A 10 meter with an angle of 60. So 10 meter with an angle of 60. This is vector A. Okay. And then vector B, 10 meter with an angle of minus 150. That means it is in the third quadrant. Okay, so it's somewhere here. So this is vector B, and then the angle here will be 30 degree. Okay, because 150 start from clockwise from here until here. Okay. So here I will use angle, I will use 30 degree as an angle for the calculation. But if you want to use this angle, is also can, that's no problem. Okay. So to find the magnitude, again, okay, the first step you have to use, you have to find Rx is equal to Ax plus Bx. Okay. So Ax is 10 cos 60 and then plus Bx, plus means minus, minus because towards negative x-axis, minus 10 cos 30. Okay, so here you will get Rx. Okay, you will get Rx. And then B, second, you have to find Ry. Ry is equal to Ay plus By. So here Ay will be 10 sine 60. And then plus, here you have to put minus because Bx is directed towards y-axis. So negative 10 sine 30. So here you will get Ry. So when you calculate, Rx will be, again, it's still the same, Cx, Cy. Rx will be 3.66, and then Ry will be, minus, Rx will, Cx will be, Cx will be minus, I just take this answer, okay, this one, and then Ry will be 3.66 meter. This is Ry and Rx. So again, to find their magnitude, you have to use Pythagoras theorem. So Rx square plus Ry square. Here when you calculate, you will get, okay, minus 3.66 square plus 3.66 square. Okay, when you calculate, you will get R 5.18 meter. Okay, this is the magnitude. Solution number 1, magnitude. And then to get the direction, number 2. Okay, this is number 1, number 1. Number 2, to get the direction. Okay, direction. Okay, and then here, the first one here is, here to get the, first one is to get the magnitude. Okay, settle for the magnitude. And then to get the direction, remember we will use theta is equal to tangent minus 1 Ry upon Rx. So here tangent minus 1 Ry 3.66 divided by minus 3.66. So here you will get minus 45 degree. So you have to check for the quadrant, okay, to confirm the direction. This is not your answer yet, okay. You have to check the position of Rx and Ry in x and y axis. So Rx is negative, minus 3.66. This is Oops. Okay, so this is the direction of Rx. Ry is positive. So this is the direction of Ry. That means it's somewhere here. Okay, it's somewhere here. Okay, okay, look at here. Look at this one. It's somewhere here. So that means this is the resultant 5.18. Okay, the position of the resultant is between Rx and Ry. So it's somewhere here. Okay, this is R, the resultant. Okay, C here. C here is the resultant. So negative 45. Okay, negative 45. We just take this value. Okay, we just take this value 45 degree. Don't you ignore. Okay, ignore the negative sign here. You have ignore it. Okay, look at 45. So 45 means is 45 from x-axis. This is 45 degree. Okay, so the direction will be, okay, you can state the direction. Okay, the direction will be, the direction will be or theta. Okay, will be, direction will be, you can state whether 180 minus 45 is equal to, okay, 180 minus 45 is equal to 135. This is the direction. Or you can state like that, like this. Okay, the direction is equal to 45 degree. Okay, above negative x axis. 45 degree. Okay, above negative x axis. You also can state like that. Okay, both are correct. Right. Okay, so you have to make okay, look at this book. Okay, look at your book. This one is wrong. This is not the correct direction, because the direction will be somewhere here. Okay, here is 45. If you want to state the direction in terms of angle, you have to compute it from positive x-axis like this. Or you want to take this angle 45, can, but you have to mention which quadrant. Or you can write it 45 degree. Okay, 45 degree, and then state the quadrant, second quadrant. Okay, so this is the direction of the resultant vector. Okay, you cannot take this one as the direction of the resultant vector. This is not complete yet. Okay, the step is not finished. Please make the correction. Okay, continue with this one. Okay, this is the way how you're going to state the direction. Okay, finish about the direction. And number 3 is unit vector. Okay, then unit vector, to find the unit vector, okay, for this example, I use symbol R for the resultant vector. You can use any alphabet. If you want to use, for example, K, it's also can. If you want to use Q, it's also can. But here I put R for resultant. So unit vector, so R, okay, so I put R cap. R cap mean unit vector of the resultant vector is equal to vector R, okay, in term of ijk over the magnitude of vector. So how you're going to write vector R in term of I, j, and k? Okay, for this example, there is no k because this is only 2D. There is only x and y axis. There are only two axes, x and y axis. So here there is no k. There is no k, only ing. So how you're going to write vector r in term of ing? Okay, so look at here. Look at, we go back to Rx. Okay, we go back to Rx. Rx is minus 3.66. And then Ry is equal to 3.66. So, for component X, okay, component X, if you want to write in term of I, it becomes minus 3.66 I. Okay. Okay, and then Ry is equal to 3.66 I. Sorry, Ry is for J, not I here. Here is J. Okay, so if you want to write it here, so R cap is equal to here, vector r in term of ing, you can write minus 3.66 I, okay, and then plus 3.66 j. This is for r. This is for r. Okay, and then divide by the magnitude of r. What is the magnitude of r? Magnitude of r is this one. This is the magnitude of r, 5.18. So here divide by 5.18. Okay, so just take the calculator. 3.66 divided by 5.18, and then 3.66 divided by 5.18. So when you calculate, you will get negative 0.706 I. Okay, I, and then plus 0.706 j. This is unit vector of the resultant vector. This is the way how you calculate the unit vector, of the resultant vector. So look at the solution here. You can see here. Look at the solution from here. Okay, the solution is from here. You have to find the magnitude, and then the direction, and the last part is the unit vector. So it's quite long. So the mark is, for example, this is only the example. The mark either 6, 7, or 8 marks for this question. So it's okay. It's quite long solution here, but if you make lots of practice about this question, okay, you can remember the step what you are going to do if you are asked to find the magnitude, direction, and the unit vector. Okay, after this, okay, let us see the notes. Okay, for the vector multiplication, okay, it's a good news. It's not in our syllabus. Okay, so you don't have to learn about vector multiplication. I will not teach you about vector multiplication, but if you want to know more about vector multiplication, you can study it yourself. Alright, so our syllabus is only stop at unit vector. Okay, so thank you for watching the video. Try to understand it and do your tutorial. Okay, goodbye. Assalamualaikum warahmatullahi wabarakatuh.